All right, this is the recording for magnetic fields, and that's going to be 1.2, our first lesson in this unit. And so you can see down here, this was either Wednesday or Thursday. The first thing I want to show you is that the new notebook for this unit, the first chapter, is on top of the module right here. So you're going to want to click into that and make your copy for the chapter. And then obviously we have the attendance, the warm up, and the lesson. On the warm up, which is the first thing that you did, you are just kind of recording some initial ideas about magnets and what they cause to happen. And so, how can a magnet launch something? And it's not necessarily like launch something like across the room, it's more kind of like move something that is maybe standing still or sitting still and being able to kind of launch that movement, not necessarily big launch. And I think that they use the word launch because it kind of relates with the scenario that we are using for this unit, which I will show you in a second. So, and then the second one is, how do you think a magnet can cause something to move? And so those are the two questions for the warm-up. And then the home page. So the warm-up and then making the notebook or downloading it. And we are completing slides 6 and 7 today. And these slides down here we used. And so I'll put myself in the top corner here. Some things that we needed was this unit, we are going to act as student physicists, and we are looking at why a spacecraft did not launch at the expected speed. And this is the video, so you're going to want to watch this. I would play it, but the screencasting doesn't really pick up sound very well, so you need to watch that on your own. Oops. Won't let me go. It goes over this idea. So they want to launch a spacecraft, and it's using magnetic fields and the force that magnets provide, and they want it to reach a target speed of 100 meters per second. And so they did a few launches. Monday, they launched it and it was too slow, and you can see right here, it only went 80 meters per second. Then on Tuesday, they moved the magnets a centimeter closer, and this time the spacecraft went 90 meters per second. So that was 10 meters per second faster than Monday, but still not fast enough because our goal was 100. Then on Wednesday, they moved another centimeter closer, and they thought that would increase it by another 10 since that's what happened between Monday and Tuesday. But it actually made it move 30 meters per second faster. So then the speed was 120 meters per second. That's too fast. And so we are going to do some research and figure out what is going on with that and why the spacecraft went so much faster than expected on Wednesday. Our unit question for this unit is, why do magnets move objects in different ways? And we are focusing on this question for our first chapter. So how can the launcher make the model spacecraft move without touching it? And so we are going to make some observations, and you can see there's some slides in here if we were doing it in person, which we are not. So I'm going to go out to the notebook. So you will see in the notebook, the first slide you're doing is slide 6. And our investigation question was, how do magnets move objects? And you're going to see that there is a box here. The first box is for hands-on, and then the second box is for the simulation. So for the hands-on, I did two things. The first thing I did was I showed I have magnets, and these would have been magnets that I would have had you use in class. And what you can see is that it has an S and an N on it. The S stands for South Pole, and then the North is the North Pole. And that shows just what pole it is, because with magnets, like poles, so these two S's, they're repelling each other. They do not want to attract it. Each time I push them closer, you can see this one's moving. I'm holding it lightly and it's moving up. But the opposite of that is if I flip it around and I have my N and my S, they attach and they are attracted. So the idea with magnets is that opposites attract and the likes repel. So the same sides repel each other, the opposites attract and pull towards each other. There is a video clip down here. Once again, another video. And I actually will show you this one because you don't need sound with it. And this was another kind of option and chance for you to see some hands-on kind of examples. I asked the class to see if they could go find some magnets in their house, and if they couldn't, this was a good option. So I'm going to play this. Oops. Alrighty, so that was just some hands-on kind of examples, and so you can use those to finish the hands-on portion. The second box needs to be filled in by the simulation, which is linked here. And you were just kind of playing around with the simulation. There's not really a task or any instructions. You're just kind of playing around with it. What there is for you to use in these slides, when you skip to about slide 27, this is a video right here to show you kind of some basics on how to use that simulation. And this one does have sound, so I'm not going to play it. You can watch that one on your own. And so you're going to use that simulation to fill in these observations over here. You should have about 2 to 3 observations per box. Those observations will then help you fill in this bottom part where it has you kind of taking your observations to finish the sentence starters. And remember, this is in your notebook, which I have over here, but I was just kind of using the slide. Makes it a little easier for me, but this is all in your notebook. The other thing we did was this homework slide, and it kind of went over some rules about magnets and kind of helped us kind of reflect on the other activities. And I will show you. We went over each rule as a class, and people got to type in the chat if they agreed or disagreed. And so this is what we came up with. We agreed that magnets attract some metals. We disagree that magnets repel wood. They don't affect it at all. And we disagreed that magnet must be touching an object to repel it. It can repel it even if it's not touching. And then magnets can move other objects at a distance. We agreed that is possible. And magnets can attract or repel other magnets. So that was that. So only those 2 slides in the notebook. And then the last 20 minutes of class or so, the magnets pretest, which you have to take a pretest at the beginning of every unit. That's what they did. And that was finished for homework if it was not finished in class, and the multiple choice only. So only do the multiple choice of that pretest, and that's that.